Hello everyone. The next motor split phase motor is a capacitor start motor. So instead of uh, highly resistor winding, we insert a capacitor in the starting wind of the single phase circuit. So there is a main winding and there is a auxiliary winding which consists of capacitor. So main winding is highly inductive, so it lags the voltage by about 90 degrees. And capacitor is the nature of capacitor is leading the current, leading the voltage by a 90 degree. So it will by adding, this is a series RC circuit, so it will uh, lead the by some angle, some angle with respect to voltage. So there is a huge phase difference between these two field, that is field produced by this main winding and field produced by the starting winding. So this 80-degree phase shift is sufficient to start the to produce a rotating magnetic field which starts the induction motor. So the starting winding is again disconnected from the supply automatically. The motor reaches speed about 70 to 80% speed of synchronous speed. So capacitor start motors use where high starting torque is required. So common applications are compressors, large fans, pumps, and some machine tools, etc. So next is capacitor start, capacitor run. So in last case, the capacitor, that starting winding is removed with the help of centrifugal switch after reaching a particular 70 to 80% of synchronous speed. But in this capacitor start, capacitor run motor, the capacitor is permanently fitted. That is, starting winding is permanently in the circuit after reaching a particular speed. So same function is happening. That is, the main winding is highly inductive, which lags the supply voltage by nearly 90 degree, and this is a capacitor which leads the supply voltage by about 90 degree. So again, uh, there is a phase difference between these two currents, so it will produce a rotating magnetic field, and that is sufficient to rotate to start the single phase induction. So the with the help of this capacitor, the power factor of the circuit will be improved. So the capacitor start, capacitor run motor is where constant torque is required. So the common applications are fans, that is ceiling fans, floor heaters, air conditioners, compressor, etc. Next is stepper motor. So stepper or stepping motor has a rotor movement in discrete steps, that is step by step, with particular degree, that is suppose by angle 5 degree, 15 degree, etc. The angular rotation is determined by the number of pulses, digital pulses fed into the control circuit. So each input pulse initiates the drive circuit which produces one step of angular movement. That is, if we design for particular 5 angle steps, that it will continuously rotate by a step of 5 degree. So hence the device may be considered a digital to analog converter. So there are various types of rotor arrangement, but we will see the two, that is variable reluctance VR type or permanent magnet PM type. So this is a wire diagram of variable reluctance stepper motors. It consists of rotors. Is a rotor. So the stator winding is connected with the help of switches, and supply is given. DC supply is given to each motor. Its phase winding. So the diagram shows 4 by 2 pole. That is 4 poles in stator and 2 in rotor. That is 4 pole. This 1, 2, 3, 4. 4 pole in stator and 2 pole. That is this pole and this pole makes 2. That is 2 pole in rotor. Variable reluctance taper. So four phases A, B, C, D are connected to DC source with the help of semiconductor switches SA, SB, SC, and SD. four phases, that is this is phase A, phase B, phase C, phase D, is connected to the DC supply with the help of semiconductors, which is SA, SB, SC and SG. The phase winding of stator are energized in sequence A, B, C, D, A. That is, first we will switch on the supply in sequence. That is SA first. The next one is SB, SC, SD, likewise. So when winding A is excited, that is this SS switch is closed, then the winding A is excited, and other are de-energized, which is not connected to the supply. Only winding A is switch is on, so winding A is energized. The rotor aligns with the axis of phase A, so the rotor is stable in position and cannot move until phase A is de-energized. So rotor is in attraction with this phase A. Next is we switch on the SB switch, that is we energize the B phase, and SA switch is open, that is de-energize the phase A. Then the magnetic field is in direction, so rotor attracts to this field and rotor makes a move of 90 degree. So next phase B is excited and A is disconnected. The rotor moves through 90 degree in clockwise direction to align with the resultant air gap field, which now lines along the axis of phase B. Third one is further excited and B is disconnected. Further phase C is excited, B is disconnected. So rotor aligns through this phase with respect to phase C, movement of 90 degree. Next is again we energize the phase D and de-energize the phase C. So the rotor aligns to the rotation aligns with the phase D. Next is again we energize the phase A and de-energize the phase D. So again rotor moves through the 90 degree. So for one particular rotation, we switch on the switch A, B, C, D, and again A. We follow the sequence in order to rotate the in clockwise direction. We can change the direction of rotation by changing the sequence. So we can start the switch SA first, but next is SD, next is SC, next B and C. That means in sequence like A, D, C, B, A. So we can change the direction of rotation of. So direction of rotation can be reversed by reversing the sequence of switching the winding, that is A, D, C. And last one is permanent magnet, that is PM type stepper motor. So in this case, the two pole, that is this stator pole, is connected by a common winding, and these two poles connected. So and permanent magnet, that is permanent magnet material is inserted, that is it has a particular magnetism present permanently, that is the S pole and N. So the permanent magnet stepper motor has a stator construction similar to that of variable reluctance motor. So rotor is cylindrical and consists of permanent magnet poles made of high retentivity steel. The figure shows 4 by 2 pole stepper motor. That is this 4 in stator pole, and these two are rotor poles. The concentrated windings on diametrically opposite poles are connected in series to form two-phase winding on the stator. So these two pole, that is this A and A dash connected. So this is make a phase one phase, and this two second phase is B and B dash is connected in series to make a second phase. The rotor poles aligns with the stator poles depending on the excitation of winding. So the two coils A dash connected in series form phase A winding. Similarly, two coils AB dash connected in series to form B winding. So this A and A dash is connected in series. So this is phase A winding, and second one is B coil is connected to B dash in series. So this is called a B phase winding. So when phase A winding is excited, south pole of the rotor is attracted to the stator phase A pole. so that magnetic axis of stator and rotor coincide and alpha is equal to 0 degree. That is this when we give a supply to phase A winding, the current starts flowing. So current starts flowing. So there will be n pole created and s pole created. So n pole of stator and s pole of rotor attracts each other. Next is when we give a B phase supply. So there will be here is creation of n pole, and so that s pole is attracted to the n pole, so it will make the rotation of the 90 degree. Again we give a current in such a way that the it will create a means we give a supply to a phase and winding. So the again here see diagram, here it is created a n pole, so that the s pole this rotor S pole attracts to this N pole and align with again make a rotation of 90 degree. Again next last phase we give a supply, so that N pole creates here in B phase winding, so that rotor S pole attracts to the stator N pole and again make a rotation of 90 degree. So likewise in this sequence, likewise, in this sequence, we start the motor, that is permanent magnet stepper. So this is end of a first chapter. Thank you.